Hello, my name is Dr. Koka, and in this video we're going to be looking at setting up the extraction experiment. So we're going to start with just going over some basics of the separatory funnel that we're going to be using in this experiment. So this is the separatory funnel, and it has a few components. So this is called the stopcock. It is currently in the closed position. So there's a little tiny hole right there where the stopcock is, which currently is facing towards the glass, the side of the glass of the separatory funnel. And when it's in this position, it would not allow any flow of liquids from the separatory funnel out of the separatory funnel. If we want to drain anything from the separatory funnel, we would have to turn the stopcock in this direction. That would now turn or place that hole facing up as well as down. So any liquids that would be in the separatory funnel would be able to freely flow out of the separatory funnel and out into Erlenmeyer or anything else. If we want to drain a liquid from the separatory funnel, we always have to remove the stopper. So generally, we want to keep the stopper on to prevent any liquids from getting out by mistake. But if we want to drain something out, we always want to remove the stopper. The reason is, as you drain something from the separatory funnel, something needs to replace that volume that is escaping the separatory funnel. Usually that's air. So by removing the stopper, you allow air to freely flow into the separatory funnel and replace any volume of liquid that was removed from the separatory funnel. If you don't remove the stopper from here, as you try to drain this, you're going to find that the draining is going to be very, very slow. And in fact, you might actually see some bubbles going into the liquid that is still in the separatory funnel, as air is actually going to try to make its way from the bottom, that same hole that the liquid is draining through, try to make its way up into the separatory funnel to replace the volume of liquid that is being drained out. So we always want to remove that stopper before we start draining. Other than that, we generally want to have the stopper on the separatory funnel. So the separatory funnel generally will sit on a ring clamp. The ring clamp will be on a ring stand. Or it could also be clamped onto the monkey bar. So the bars that are on inside of a hood are called monkey bars. Either way is fine. So once we have it placed on the ring clamp, we want to now take our unknown. So every student would be given an unknown, and you're going to weigh out approximately 150 milligrams of that unknown. That unknown is impure, is going to contain about 2/3 by mass of a neutral compound, meaning a compound that doesn't have any acidic or basic functional groups. The other third of the unknown is going to be made up of an acidic or a basic impurity. So a compound that has an acidic functional group, carboxylic acid to be exact, and or it could have an impurity that has a basic functional group, amine. So you don't know which unknown you have, first of all, what neutral compound you have, or what impurity you have, whether it's acidic or basic. But through following the procedure, you can figure out both the neutral compound as well as what impurity you have. So the two impurities can either be benzoic acid if you have acidic impurity, or it could be 4-chloroaniline if you have the basic impurity. Okay, so we have weighed out the 150 milligrams of our unknown, and we're going to add now 5 to 10 mLs of ether. So ether has another name, by the way, called diethyl ether. That's the proper name. We often call it ether for short. So we have measured out 5 milliliters of ether, and we're going to pour that into our beaker. And we're going to stir that a little bit, and we can use a pipette to stir it, or a spatula, anything will do really. and you'll see that this unknown has gone into solution completely. It looks like ether is a good solvent for the extraction. If you find that your unknown does not dissolve in ether, you would have to sort of weigh out another 150 milligrams of the unknown. Just try to dissolve it in dichloromethane. So all of our unknowns in this lab are either going to dissolve in ether or dichloromethane. So dichloromethane is going to work pretty much the same way as ether in this experiment, other than because of the density differences, ether generally is on top of water, it's less dense than water. Dichloromethane is generally more dense than water, so throughout the extractions, the organic layer, dichloromethane, would generally be on the lower or be the bottom layer. Other than that, they should behave the same way throughout the extraction. Okay, so at this point, we can add our unknown in ether to the separatory funnel. One thing you always want to make sure is that the stopcock is in the closed position. You never want to put something into there and then have it come out the other side because you left the stopcock open. Okay, we also want to remove our stopper, and we can now add the unknown to the separatory